We're going to have some fun today. I'm talking about event-driven systems and what that means in the Java world. My name is Richard. I work at Pivotal, company behind Spring Framework and Cloud Foundry and Greenplum, RabbitMQ, a lot of open source tech. I'm joined here by my neighbor over here.
Asu Singh. I'm in the Java on Azure engineering team. We are so happy to be here today, show you the real-time systems.
Yeah, we're going to have some fun. So we'll have some demos for you. We'll talk a little bit about all the tech that powers a decent event-driven system. And of course, when you look at event-driven systems, they're all over the place, right? You order coffee, somebody triggers somebody to go build something for you. You go ahead and process a loan, and that moves as a series of events as you close a loan and fund a loan. And all these things are not a synchronous process. They're chained together as a series of events. And look, even calling up and complaining about something, that triggers a series of events into an investigation into tech and things like that. Even reading your email, of course, you're not going to do that here because this is an amazing talk, but if you were reading email here, that's all event-driven, right? It's getting pushed to your phone. So in these sort of systems, you're not just polling for things. You're actually responding to something happening outside. So if you look at a decent event-driven architecture, we typically see kind of a couple of different categories. What are you looking at from an architectural perspective, right? If you're building an event-driven system, which is different than what you might have been doing up till now, what do you kind of expect out of your architecture? Well, you expect some more decoupled components. I expect things that I can scale independently. I expect things that are broken up so I can actually have different pieces responding to different events. I also have things that are trigger-friendly. Obviously, if I'm doing events, I'm waiting for something to initiate that event. So my database has to have a way to emit something. It has to tell me something. My logging system maybe has some observable endpoint that I can do something with. So any sort of event-driven system, I'm going to need something, whether real or even maybe a shim, that can actually trigger events. Of course, you also have things like scalable infrastructure. The whole point of a decent event-driven architecture is that you're responding to things elastically. And you might get a blast of events. It's Friday afternoon, everyone's submitting their payroll or their timesheets, and it blows up your system. No, you want to scale to that event and then be able to scale back down. And of course, you think of state and stateless. A lot of these systems, especially when you think of functions and serverless, a lot of this is around stateless operations. Something spins up, does some work, shuts back down. If it has state, it stores it in some attached object storage or file system. And of course, you need flexible storage. We'll talk about that today, but you need different types of databases. You're probably not just using a relational database system as your only storage medium in an event-driven architecture. And then you're looking for some sort of extensibility. How do I make sure I can extend these sort of things while at the same time being able to observe and trace these? I have to make sure that I can see what's going on, because I don't know about you, if you've built a decent event-driven system, you'll notice that it's harder to track what's going on because different things fire at different times in response to a different event. So how do you piece it all together? So if a customer calls and says, this didn't work, how do I connect where the thing came in and got triggered and 4 things picked it up and processed it? So all of those things come together. If you don't have those things architecturally, you're going to have a tough time with your event-driven system. But Oscar, as we think about how Microsoft Azure helps, what do you think of when we think of event-driven?
So when you come from that architecture, right, the first thing is we have managed services across the board. Whether you are ingesting data, we have managed event hubs. We're storing data, we have managed Cosmos DB that you can store across the globe. Whether you're running serverless code, we have managed serverless runtime. If you're running apps, web apps, then you have managed app service across the globe, so you can just deploy them, right? And they are global, instant scale. You know, Azure is supported across 54 regions today, and we continuously add those regions. And we have a robust serverless functions platform where you can run your Java code, right? So, and we also have a high throughput, very high throughput. And if you take Event Hub or you take Cosmos DB, they elastically scale to meet your demands. Now, how much you want to store? You can store as much data as you want. Your limit is nothing but your credit card at that point, right? How much you want to store. And security is just across the board, right? Even if you take, for example, Cosmos DB, you're encrypted at rest as well as in motion. Everywhere, all the data is encrypted. So it's a fully secure managed services across the board to help you here.
Mm-hmm. Yeah, so you've got some architectural considerations. You have some things specifically that Azure helps with. And then when you look at Spring and platforms like Pivotal Cloud Foundry that run atop Azure, so Spring itself has all kinds of libraries for reactive programming. We talked about more this week at Spring One Platform, where we were also add in hanging out, and a number of things for stream-oriented apps, right? I'm looking for frameworks that make this stuff easier. I don't want to force my developers to build the primitives to actually read from a stream, increment things. I want it to be simpler, and things like Spring Cloud Stream take care of that. At the same time, Spring's got a function paradigm, Spring Cloud Function, which we're actually going to demo for you today. It just got support for Azure, which is great if you're looking at building Spring-based apps. If you want to use something like Pivotal Cloud Foundry, it's a platform as a service, if you will, that runs on any infrastructure, public, private, every public cloud. So you're looking for something that can scale your applications. I need that elastic infrastructure. And it runs batch apps. You can do stream processing. You can do function app, web apps, all sorts of different things. And of course, I can put this everywhere. I could put this at an edge location. I could go put this on my OpenStack environment. I could put this on Amazon and Azure and GCP. So the point is, I want to be able to run events all over the place, potentially using things like Spring. And if I choose to, then some great technology in Azure. So these are things that start to piece together as I think of the tech stack. Now, Asser's team did a pretty terrific job building this architecture, which we're going to demonstrate for you in a moment. Do you want to talk through some of the core components here?
Yeah, so imagine you're running a coffee shop, right? They're building a real-time inventory systems where there are coffee shops up and running, and customers are coming there buying stuff from the coffee shop, and then there's inventory coming in through your warehouse or you're intaking into the store, right? Imagine such a system where all the data, right, everything is an event. Everything is coming in as a transaction, and you want to draw some meaningful insights from that system. Now, when you look at this picture, you can see the coffee shop is up and running in Boston. So there are many, many coffee shops and many, many events that are happening, sales, intake, right? And there are another set of coffee shops in London, right, where similarly all the coffee shops are up and running and sending them as events, right? There are 4 major things in this architecture, right? The first one is the ingestion of all the events, right? Whether it is a sale or an intake, or whether you are notifying somebody that a transaction happened. So this is where we are using a managed event system in Azure, which is the Event Hub, right? Which is one of the central piece here. The second one is the serverless code, right? When the events arrive, these serverless code get triggered, and they are running on a managed system there. So when a sale arrives or an intake arrives or inventory is updated, it gets notified. This is when the serverless gets triggered and it acts in reaction to that. So that's the second one. The third piece is your managed NoSQL store, which is Cosmos DB. It's across the board. You can see them, right? Here they are. Cosmos DB supports read and write replicas, so you can put your reads close to where your users are, particularly if they're reading the information. And for all the writes, you can put it very close to where the writes are. And the fourth piece is the dashboard, right? So dashboard is nothing but a Spring Boot app, right? And it connects to the Event Hub using a Kafka stream, using the Spring Cloud Stream Binder for Kafka. And that's how it connects. Now, this particular Spring Boot app, it also uses Spring data for connecting to Cosmos DB. So if you're a Spring developer, you should be very familiar with the Spring data paradigm, Spring Cloud Stream paradigm, and the Spring Boot apps, right? All you have to do is write Spring Boot apps, and you can run them anywhere. You can run them in Pivotal Cloud Foundry on Azure, or you can run them on Azure App Service, so you get the massive scale and across the globe for you, right? So those are the 4 pieces. So what we are going to do today, live from here, first we'll show you the dashboard up and running for Boston as well as London. Live from here, we're going to expand the operations to Singapore, right? So when we expand the operations to Singapore, you can then start seeing the meaningful insights and the events coming in from Singapore from here. So that is what we are.
Yeah, and we've got, again, a shared database. We'll talk about each of these components after we finish the demonstration, explain why Cosmos plays a big part here, Event Hub, Spring, all of these technologies. Why are these helping us build a more event-driven system? And what we're going to show you is actually adding this Singapore location without any disruption to the overall processing. We have decoupled components. We've architected this well. So you can hit these URLs in your phone and actually be seeing this live as well. So if you hit these URLs, you'll actually hit the dashboard, and as we add Singapore on there, you'll actually see those new events start popping in there, which is pretty neat. So I'd like us all to try to break Oscar's system. His team worked hard on this. We should be trying to do a denial of service here as a team. Let's hope. All right, so let's go ahead and do the demonstration. Let me go ahead and flip to your screen. And we'll see here what the dashboard and kind of the live event stream over here on the right.
So you can see the events coming in. On the left is all the events are coming through. On the right is the dashboard, where you can see a tally of the inventory right now. So you can see in Boston, the whole of Boston, there are a few shops up and running. You can see the inventory and the positions of the inventory. Similarly for London, right? So what we're going to do now, we are going to start expand the operations to Singapore, right? So while we expand, we'll also show you some code bits so you can see how we are accomplishing this, right? Okay, so let me go into my IntelliJ here, right? So
is this readable for folks in the back? Or make it a little bigger? A little bigger? Do you mind?
A little bigger? Okay. Right. I don't think it's moving there. It's probably a...
No? Okay. Well, we'll make sure we talk through it nice and clear.
Yeah. Okay. So here you see a simple Spring Boot app, which is actually a Spring Cloud function, right? If you look at the center of that piece, there is a function there which actually receives an event, which is POJO, and then process it and transforms that into a document which gets stored in a Cosmos DB. Right? The event is an event that arrived through Event Hub. Right? So let me show you the POJO that describes the event, which is right here, which is a simple, plain old Java object here. Right?
And this is a sale transaction, right? So we're describing where this sale came from and what it is.
Yeah, it's a very simple one that has a bunch of complex another POJO embedded in it, which describes where exactly the transaction happened. Now, once we have that data, we can create another one which will be serialized into Cosmos DB. Right? So the way it gets bound to Azure is there is a way to bind it there. Right? So you have a trigger using annotations. You can explain which event hub is going to trigger this piece of code. Right? Now, once it gets triggered, right, it gets processed. Where will it get bound to? Right? So in this case, it's a Cosmos DB, where the output is getting bound into a collection. Right? So this is one example. I'll also show you one more example.
So again, for everybody, this was when something hits that event hub, it triggers this function, takes the result of that data and puts in that particular Cosmos. So kind of a neat way to stitch together things here.
Yeah. So here is how we are simulating a point of sale or a point of intake. It's a timer where it is picking up based on a certain time and it starts putting into Event Hub, which will be then picked up for processing by another serverless code. Right? So what we did before we started this session today is we provisioned all the resources in Singapore. We provisioned the replica for Cosmos DB as well as the Event Hub, which took us about 6 or 7 minutes, which we did just before I walked in. That's what I was sitting and doing outside to make sure that it is ready to go. So now what we're going to do is we're going to deploy it in Singapore live from here. So to deploy in the Java experience, all you have to do is, as a developer, I would compile the code using Maven. Right? I can package the code using Maven, and I can just deploy the code using Maven. That's all I have to do. And then you will see the deployment come through. Okay?
So you're going to be deploying these functions specifically?
Yes, I'm going to deploy the point of transactions into into Singapore at this point, right?
Awesome. If you can, maybe we'll make this one a little bit bigger if it doesn't mess you up too much.
Let's see. Yeah, I think this one I can make it looks like. This one reacted, right?
That's right, it did.
Okay, good. So the first thing as a Java developer, I'll just do a clean package. Right, so it'll quickly package it. And once it packages it, all I have to do is call for a deployment. Right? Now, while it is packaging, let me also show you the dashboard app that you were able to see a few minutes ago, right? So here is the Inventory Hub dashboard app, right? So the dashboard app is nothing but a Spring Boot app, right? So if you're familiar with Spring Boot, you will recognize all the signatures there. We also mentioned that we are using a Spring Cloud Stream. So you can see the Spring Cloud Stream signature right here. Import Spring Framework cloud.stream.annotations, right? So to make the Spring Boot app listen to what's happening in the Event Hub, all we had to do was to go here and add a listener, right? That's all we had to do. So once we put the listener in, then the transaction messages start flowing in, right? So in this case, the notifications are coming in, and that's all it needs to do. So I'll also show you how it is configured. It's also configured in just the way that Spring Boot developers would do, right? You can see that we are using a Kafka binder for Event Hub, where you can see various configurations right there. And they're all using dollar parameters. So what happens is the secrets that you need are bound at the runtime and not at compile time.
What's key is there's no code in there that's Kafka specific or RabbitMQ specific or Event Hub specific. Right. You just wrote an app that responds to an intake stream. So that's some of the power there. Spring Cloud Stream is pretty amazing stuff. So I'm glad you used it. So
the build is successful. So we are going to deploy now. So we have a special plugin for Azure Functions. So all I have to say is deploy at this point. So the deployment is kicking into Singapore, right? So while we get that, we can also get this up and running here, so we can see what's happening. So you can see that London transactions are coming in, and you can see the Boston and London there. Shortly, you're going to see Singapore when the deployment succeeds at this point, right? So, yeah. So while that happens, we can also show you a few more pieces of code that we have used here. Mm-hmm. By the way, the code is actually online. If you want to see,
all in GitHub, so you can.
They're all in GitHub, right? The deck carries a link, so at the end of the presentation, you would see a link to this particular repo. Let me expand a bit so you can see the full one. So here, you have the code and all the instructions to run it. It also carries the picture that we just showed you as well. So that's in the first page, I believe, here. It's right here, right? Where you have the dashboard app is here, and the deployment scripts are here, and the function app is right here. Mm-hmm. I also want to show I'll show you one of the other functions as well. So totally we are using 4 functions as you saw in the picture, right? If you take, for example, notify inventory, in the case of notify inventory, here it is. Here is the notify inventory, where when the transaction, when the inventory is updated in the Cosmos DB, so when that action happens there, it wakes up the serverless piece of code, right? And then starts notifying to all the listeners. In this case, since we have numerous dashboards, we just have to put it in the queue, and the dashboards will start listening to a Kafka stream in the Event Hub. And then they will then they will receive all the messages like the way you just saw right here. So let's go back here. Let me resize it a bit, right? So it should be coming here. Let me check the deployment. Deployment is still running. You can see it.
Yeah, did you want to jump to the Azure portal as well? Or
Oh yeah,
just finished?
just finished. Yeah, the next one is to go to Azure portal, definitely. Should we wait? Or?
Yeah, now I'm waiting for it to pop up as soon
Yeah.
as I said that.
Yeah, so at this point, it'll start up in the back end, and we just have to wait for the events to start kicking in.
And again, since you published this to the single Cosmos DB kind of database fabric, you didn't have to really change any of the dashboard pieces. They just still pull from the same Cosmos endpoints. They're just now getting Singapore data.
So you see two screens. The first one on my right is actually, Singapore started showing up right now. You can see Singapore coming live into the system, right? Yeah, Singapore events are coming through. So on my right hand is going through an auto refresh. We put a 5-second auto refresh. But on the left, it's actually coming through a WebSocket, right? Now, writing WebSocket code using Spring Boot is very simple, right? You just have to use the Storm library, and it's a very simple way of writing it. Okay, yeah, Singapore is coming through. You can see it on right here. Fourth event, fifth event, sixth event, seventh event, they're all coming from Singapore, and you can see. So now you can see how responsive it is. We only wrote very small fragments of code, right? We had 4 functions, and we have 1 Spring Boot app, right? And there are many managed services. The Event Hub, Cosmos DB, App Service. You can also run in Pivotal Cloud Foundry on Azure, and Azure Functions, right? That is how we got to.
Yeah, let's talk about some of those then.
Should we show the portal at this point? Later, we can come back later.
Yeah, let's see if we have a little extra time.
Sure.
So let's jump through some of the actual pieces then. So what makes up a serverless sort of event-driven architecture and all of that? So we'll walk through some of those core pieces that matter here. We talked about them, but let's give them a little more attention. So Cosmos DB. So you're a father, right?
Oh?
You're a father.
Yes.
You're not supposed to have any favorites, but this is kind of my favorite. Just don't tell the other services. But Cosmos is pretty cool. It's probably the neatest thing in Azure. So it's an actual globally distributed multimodal database. It's a key value store. It's a document database. I can do graph database in there. So it does a number of really interesting things. Mm-hmm. And if we talk about some of the specifics, so multi-region replication. Now, actually, this week at this conference, Microsoft announced that this is also multi-master. So it's not just read all over the place. You can actually designate different locations to actually do multiple writes as well and have that synchronized, which is pretty amazing. Lots of different consistency choices. So I can do strong consistency, I can do session, I can do things on a per request basis, which is actually pretty cool. So each request could have a different consistency demand as I submit a request. I can do eventual consistency for certain workloads, or I could actually do a tighter consistency if I needed to. Extremely elastic storage, as Oscar mentioned, it's pretty much limited by your credit card, but it's an important thing to know that I don't have to pre-provision. Now again, I think this week as well, you actually announced pre-provisioned capacity for Cosmos DB, which was interesting. As we talked about, a lot of different models. What's also kind of unique is that Cosmos serves up APIs that help it mimic other databases. So it can look like MongoDB, it can look like Cassandra, or it can just have that sort of native API. So if you have code that talks to MongoDB, you can literally just change the connection string and talk to Cosmos, and it just works, which is pretty neat as you think about migration, or even just think about, hey, I don't want to go refactor my code to take advantage of this new substrate. I don't really have to. Automatic indexing, all the sort of things DBAs love to do, as we talked about, encrypted at rest. So this is a pretty fantastic database choice if you're looking for something in a NoSQL capacity, so definitely recommend that. The next piece that makes up, so storage, as we talked about, super key. As I think of elastic storage, I think of maybe even event sourcing and want to store raw events and documents, but then it goes into the transport component, right? In a decent event-driven architecture, transport matters a lot. So what's event hubs?
So we live in a world of events, right? Everything is an event, right? In the retail one that we just showed, every transaction, every intake, everything that is coming through is an event. So what you need for this one is a fully managed, right? So Event Hub is a fully managed event scale ingestion for all your events, right? It can handle the volume, variety, and the velocity here, right? It supports all the languages, including Java. So if you're using Java, We have a Java library to bind, but if you're very familiar with Kafka, we also support Kafka as an endpoint for publishers and subscribers. So if you use any of the tools, any of the libraries that you have in the ecosystem, you can just start connecting to them, right? You saw how we were connecting to event hubs using the Spring Cloud Stream Kafka binder, which is a very generic binder. You can just connect to event hubs. The other important thing you get from event hubs is that it's well integrated with all other services in Azure as well. One of the important things that we showed you here is the functions. From functions, it is natively bound, right? So when an event arrives, it auto triggers a function to start executing in Azure Functions. So that's an important piece of the puzzle here.
Yeah, so the next piece, we think about functions. We can still have apps that do things, but obviously with the serverless paradigm and this idea of elastic compute, what do we think about with functions? What is this as a framework?
So this is a fully managed functions runtime, right? So all you have to do is bring your piece of code, and it can be triggered in reaction to an event, whether the event is happening in Azure or from outside. And we have native integration with key event sources like event hubs, Cosmos DB, storage, event grid, service bus, and many more, right? So there are triggers, and once you have the triggers, then you can natively bind the data, whether the data is inbound or outbound. In our case, when the sale happened, right, an event hub message arrived. When you have that event hub message, you need a lot more information to process them, right? So you want to get the data directly from Cosmos DB. So as an input binding, it can bring additional information. So once you process, you can bind them as the output. So we have native input and output binding in the service. And it supports all the programming languages, including Java. And for Java, our programming experience is very simple. You saw me how we use the Maven plugin to compile and package it, and then just deploy. Now, I can also locally run it, right? Once I locally run it, those events and the triggers are bound to my local dev box right here. So when that happens, I can just start stepping through my code, right? In IntelliJ, Eclipse, or VS Code, or any tools of your choice. And of course, you can use the tools you like, whether if you're wiring up for CI/CD, you can also use Jenkins. So Maven, VS Code, IntelliJ, Eclipse, and Jenkins.
Yeah, awesome, thank you. So the next piece to think about is you think of, okay, you have the runtime, how do I actually build the function? And of course, I can just write regular Java code, I can just write C# or multiple languages. Spring Cloud added Spring Cloud Function last year. So this is something we at Pivotal shipped and released. And so basically, it's how do I ship business logic as functions? How do I have boot-infused applications that take advantage of all the things in boot? So I like auto configuration, where it configures and suggests the right beans to load and make sure that everything's loaded up, dependency injection. How do I get advantage of all of that, even in a serverless platform? What's pretty neat is, again, as a runtime, this runs anywhere. You can run this on your desktop. You can run this on a virtual machine. You can run this in Azure. These are just sort of quick running functions that are able to shut down immediately when they're done. So I can take advantage of all kinds of things. You can even set into class to an endpoint, and it will auto-compile that as a function bean and then instantiate it. So I can actually add functions that way. I don't even have to write code ahead of time. I can actually pass in the function itself to generate the function. So what's also neat is partially through the technology of Stream, but I can take a Spring Cloud function and invoke that via HTTP or via something off of a message bus, whether that's something like Event Hubs or Kafka or RabbitMQ. So also really neat that my code has no knowledge of how it gets invoked. I've been able to separate the invocation from the function, which gives you a lot of portability, flexibility, and usage flexibility. By itself, when you run Spring Cloud Function, it actually has the registry of all the different functions and how it uses them. And we actually wrote a good, Dave Sire wrote a blog post this week on how we've kind of reconfigured Spring Cloud Function to also support Azure. Now, what Oscar showed you was a lot of annotations in code that had things like bindings and triggers. You can still do an external JSON file if you don't want to have that in your code. You might say, look, I want my function code to be pure, have no references to the runtime, So I could actually run that locally or in Azure in another cloud without changing code. You can also just attach a JSON file that has those same sort of triggers and bindings. So it's up to you how coupled you'd like to be. Next thing we want to talk about is the app server Linux. So again, in an event-driven architecture, not everything is probably going to be a function. So when I actually have to run a server, I have to run a long-running thing that listens for things. Tell us about app service.
So this is a fully managed app service platform. So you can bring your WAR or JAR, Java Web App files, and all you have to do is use the Maven to deploy, or you can use Jenkins to deploy. Once you deploy, it'll be up. The key things here is, since it's a fully managed system, when you bring your WAR or JAR, it has auto scale, it can do load balancing for you, auto patching for you, and you can secure those apps using Active Directory. And since it's Java, we also announced this week that Azure support will give you free LTS Java support across the board. So any changes here, whether the runtime, auto patching, definitely will help you. And when you're developing here, you can bring your own tools, right? You can use Maven, IntelliJ, Eclipse, or Jenkins. And also you can use your APMs of your choice. You can use New Relic, AppDynamics, and Dynatrace. All you have to do is change an app setting to start loading your agent, and then it'll start, and you can see all your profile information as well. We also have some built-in tools, so you can also do some troubleshooting. So it's a fully managed app service platform for Java.
Mm-hmm. Yeah, and another choice that's complementary is something like Pivotal Cloud Foundry, created by Pivotal. And so what is this? Well, it's a cloud-native platform for any IaaS. Basically, if I want to run all sorts of different software on any infrastructure pool, I use something like Cloud Foundry. So the point, if you use this when you're trying to get better at delivering software, I don't want to deal with the muck of setting up DNS and load balancers and firewalls and packaging my app. I really just like to go from source to running app in a highly available way. Offers all sorts of interesting ways to do security, constantly repaving the virtual machines under the platform, replacing them with gold images. But it's very app-centric. You don't deal with infrastructure. If you want to SSH into a container, go for it, but you don't need to. All sorts of languages, as you'd expect from any sort of platform, Java, .NET, Node, Ruby, Go, Python, PHP. It does cater, of course, to Spring Boot, and .NET. So if you're a .NET developer, we built a library called SteelToe, which has gotten pretty popular, that also does microservices for .NET. Both of those kind of get represented in a special way in the developer UX, so I can actually troubleshoot actuator endpoints, things like that. And all the infrastructure is automation. If I want to deploy to Azure, it's a one-click from the Azure Marketplace or via some commands. If I want to roll through the new Windows 1803 update, Windows Server, it's automated. There's no downtime for your apps. So that's a key part of that. And a lot of message services, as Oscar talked about. So a lot of different ways you can choose to run your event-driven apps. The one thing I know we like collectively, Microsoft and Pivotal, about this is there's things I'm going to do on-prem, there's things I'm going to do on public cloud. It's nice when I'm using the same sort of platform across both. So when I run these two together, yep, you can use the marketplace. You can run this in the government cloud. What's also nice is if you deploy this, we take advantage of all the native stuff in Azure, things like Azure Storage, Managed Disks, components like that. And there is a service broker. If you've heard of the Open Service Broker API that came from Pivotal and Cloud Foundry, now it's being used in Kubernetes and a lot of things, which is awesome. But if you want to say, like, look, I want to run something like this on Azure, but I don't want to lose access to these things we just talked about today, Event Hubs and Service Bus and Cosmos, the service broker makes it really easy to discover those things, connect to those things, and then even disconnect when that app changes. I can integrate with day 2 operational support, things like log analytics, and even using things like Azure Active Directory for single sign-on. So again, the point of all of these components is, again, how am I building these sort of things to take advantage of these different really interesting novel subsystems that exist in Azure in something like Cloud Foundry. So it's a few things I hope you do at this point. That Inventory Hub project's available on GitHub. You can fork it, change it, do whatever you'd like to do with it, but experiment with event-driven apps. The Java on Azure site is surprisingly great. Like, Microsoft's doing some really impressive stuff in the Java space. You have a ton of Spring articles as well, just regular Spring on Azure stuff. It's really a sincere effort by Microsoft to do some really impressive work for the Java ecosystem. And then Pivotal as well. We have a number of resources to help you get started with this sort of architecture, as well as explain how we can connect better in your Microsoft world. So together, hopefully that makes it a much more interesting place to build event-driven apps.
Yep.
So with that, appreciate the time, and we'll be up here if you have any questions.